Hello everybody and welcome back. We're on question 13 now of our mock midterm style question test thingy that was posted. And question 13 has a limit as x tends to negative infinity of sort of a rational function. It's got x to the 1/3 up here, so it's not technically a rational function, but it's close enough. It's powers of x multiplied by constants and then added or subtracted together over powers of x multiplied by constants and added and subtracted together. So it's another infinite limit, but a different style of question to the last one, question 12, which was an infinite limit that we sort of had to chase through. So with this sort of a question, there's a couple things we can do. We could maybe perhaps remember the way we talked about this in class, and that you can compare degrees and look at things like that. But I think probably the easiest thing to do is just to, let's write these guys down, rewrite the questions, getting rid of the highest degree polynomial, or highest power of x, I guess is what I want to say. Okay, so x to the 1/3 plus x squared, 1 plus x plus 2x squared. So the way I go about the question like this is I say, well, we're going to one of the infinities, highest power of x. Let's see if I can spell properly today. Highest power of x is x squared on either the top or the bottom. It's the highest power, period. Okay? So I rewrite the question by multiplying by a sneaky 1. And my sneaky 1 is based off this highest power. We did have a question like this in class. That's good to review. So I multiply by 1 over x squared over 1 over x squared. It's the same thing on the top as it is on the bottom, so it's technically 1. And multiplying by 1 doesn't change what you're talking about. But it can change how you view it. So now when I multiply through here, I get x to the 1/3 over x squared plus x squared over x squared all over 1 over x squared plus x over x squared plus 2x squared over x squared. Now, there's a lot of simplification that can be done using our rules for exponents. Number on the top, number on the bottom, same base. You subtract the exponents. So 1/3 minus 2, that's 1/3 minus 6/3. That's x to the negative 5/3, or we might say 1 over x to the 5/3. And plus 1 over x squared here, 1 over x, and then 2. Just plain old 2. Let's write him a little bigger. Okay. Now, what can we do here? Well, we can bring the limit through using our quotient rule, quotient law, sum law, all those other fun limit laws. They finally get to come into play. Okay. And you might remember from class, we had a rule that said if it was limit of 1 over x to some positive rational number, that goes to 0. Okay, so that means, well, this is the limit of x going to some positive rational number. That's 0. That's 0. That's 0. Now, people who are like really studious will take me to task on this. That specific rule I'm quoting said it has to be if its limit as x goes to infinity, sure, whatever, everything goes to 0. But the rule did say, well, it's a little tricky if x is going to negative infinity. If x is going to negative infinity, because we want to make sure that this isn't a does not exist sort of thing. If x is going to negative infinity, you have to be sure that the 1 over x to the rational number, that the x to the rational number is defined everywhere. Well, x to the 5/3 is defined everywhere. X is defined everywhere. X squared is defined everywhere. Okay, so I rushed a little bit through that, but we do need to do those double checks, because otherwise we can't turn all these into 0. So here's a 0, here's a 0, here's a 0. And what's the limit as x goes to infinity, a negative infinity of a constant, just that constant. So this all becomes 0 plus 1 over 0 plus 0 plus 2. The limit, finally at last, is 1/2. And that is an answer of C. Okay. Now, if you remembered what we talked about in class, you could have just said, well, just take the coefficient of the highest powers and have a fraction like that, 1 over 2. That would have been fine. Wouldn't have been a problem. But we actually used our limit laws here. We wrote it out nice and neat. We got an answer of C. So that's question 13. In the next video, we're going to go through question 14. But do be sure to give it a try. Practice question 14 before you just watch me do it. And I will see you guys in the next video. Ta-ta.